Okay, now we move to the when the area bounded by the two curves or a line and a curve. So now we look at these two sketching. Alright, so these two sketching got two functions, which is y equals to fx and y equals to gx. So for this case, how are we going to find the area? We will subtracting the upper function, which is fx, minus the lower function, which is gx. So this would be the formula when we have two curves or two functions. We have limit from a to b. So we have limit from a to b, and the upper functions is fx, or we could have another color in order to identify which function is larger than the other function. So when I draw a line here, okay, so we could see this function and this function, the fx is above the gx. So now fx is the upper function, gx is the lower function. So the upper function will subtract the lower function, fx minus gx. So for the right side sketching, okay, we do have also two curves. Okay, this is first function and second function. So for this case, we gotta look the function at the most right, and then which function that will be to the left side. So when I do a line of horizontal here, so fy is at the most right and gy at the most left. So in this case, fy is the right function, and while gy is the left function. So the same thing, limit we are taking from c to d. Okay, the integration of c to d, then fy minus gy, the most right function, subtract the left one. Okay, because we are referring to the y axis. So I think all of you have the idea on how to solve the area within the two curves. Okay, so again on the left side here, so we are taking the most upper minus the lower function because we are referring to the x-axis, while on this side, okay, we are referring to the y-axis, then we are taking the most right, subtract to the left function. Okay, so these are the two formulas that we are going to use after this when we have two functions or two curves. Okay guys, this is the paragraph, okay, which explain the similar things that I just explained to you. Upper function minus lower function for x-axis. Okay, we could see from ds here, and this one is the formula for two curves or two function, which is right minus the left function for when we are referring to the y-axis. Example 16. Calculate the area of the region bounded by the curve y equals to x squared plus 3 quadratic, the linear function 3y equals to negative 2x plus 14 and y equals to 3. So first, I think let's we represent this function as a y1, this one as a y2, okay, the last is a y3. So to find the area of the region bounded, okay, so by these three functions, okay, we have quadratic and two linears. So first of all, as usual, it is better for us to have the sketching first, because from there we will see and identify which the regions to be bounded. Okay, just a very simple sketching here. So we have yx squared plus 3, so this is a smiling graph which will cross the 3 here. Okay, y-intercept, y2 is a negative, okay, so negative gradient. Okay, so let's sketch. So we know the first quadratic will intersect at 3, so just a simple sketching here. So the most basic one, oops, okay, we're gonna use the different color. So first, okay, take the blue one, okay, something like that. Okay, next, okay, this graph is will have a negative gradient, and then the y-intercept, use the purple color. So y equals to negative 2 over 3x plus 14 over 3. So we know the intercept will be at 14 over 3. That is about 4.7 something. Let's say here is 5. Okay, just a simple sketching. Okay, the last one is a y equals to 3. So y equals to 3. Okay, take orange. Y equals to 3. So this is y equals to 3. This one is 3y equals to negative 2x plus 14. While this one is a quadratic, y equals to x squared plus 3. So now, where would be the area of the region located? Okay, so try to guess. Is it here? I think here, because it looks nice to be there. Is it correct? Oh, is it here? Okay, so if you see here, guys, I have sketched this sketching by using 3 colors, so that you could see the difference between the curves, between the line. Okay, and then the question tells us this region must be bounded by the 3 curves, the 3 function. So it must be bounded by the blue color, okay, which present this function. And then this region also must be bounded by purple color, and also this region also must be bounded by the orange color, by these 3 colors. So if you look at the first here, if you think the region is here, you see on the left side they are open to the left side. So this one is not be bounded by any curves because it is open to the left. How about here? So now bounded by the purple color, purple line, bounded by the blue color, but it is not bounded by the orange color. Okay, and then what you do if we look at the last region here? Okay, this region it has been bounded by the blue color, the purple color, and the orange color. Okay, class, this is the region that we are going to find the area, because the 3 colors which represents every function here, y1, y2, and y3. Here is y1, here is y2, and here is y3. So now firstly we have to find the limits in order to find the area, because when we have limit, then we have can find. Okay, referring to the x-axis, so we could see the limits here. So here, and of course here. So we have to find the intersections points at this point, at this point, and at this point. Okay, first intersection points between this y1 and y2. So how to find intersection points? So what we do, okay, we equate 2 of them. y1 equals to y2. It's just like what you learned in your school. To find the intersection points, okay, we are going to equate these 2 functions. y1 equals to 1, 2. So y1 is x squared plus 3, while y2 is negative 2 over 3x plus 14 over 3. So now we are going to solve them. 3x squared plus 9 equals to negative 2x plus 14. That will result to the quadratic equation, which is 3x squared plus 2x minus 5 equals to 0. And then this quadratic could be factorized. Yes, it can be factorized into 3x plus 5x minus 1 equals to 0. So from here we know that the x equals to negative 5 over 3, and also x equals to 1. Okay, so the intersection points here is 1. So negative 5 over 3 is actually somewhere here, negative 5 over 3, but we won't use this point as the region is not here. Okay, so we have to find another 1 point, which is here. Here is a 0. We know that there is a 0 there, so here is 1. And then this part. Okay, for this part, use the orange color to find this intersection point. Okay, we're gonna equate the y equals to 3 with the purple and the orange. The purple, so y2 equals to y3. Okay, so y2 equals to y3. So y2 is negative 2x over 3 plus 14 over 3. y3 is a 3, so negative 2x plus 14 equals to 3 is 9. So x equals to 5 over 2, 2.5. So here is a 5 over 2. So now let's begin to find the area. Okay, let's restart. So this is the sketching that we have is now. So we're going to find the area. Okay, when we look at this region, okay, I have to spread them up into two parts. Okay, which is, here is a part A and here is a part B. So why should I spread this up into two parts? Because every single parts here, there are limited functions involved. For example here, okay, if you look closely to the part A, only two curves involved here, which is the blue one and the orange one. On the next side, okay, when we look at the part B, also the curve involved here is only the orange one and the purple one. So the area, so I am taking from beginning point from 0 to 1. So for part A, so which one is the upper function and the lower function? So of course the blue one is the upper function. So y1 is x squared plus 3. Okay, we will subtract the lower function, which is the orange one, which is y3, 3. Okay, so with respect to x, plus, okay, you want to add up with the second part of B, which begin from point 1 to 5 over 2. So for part B, okay, look closely. Okay, there are only two curves involved here, the purple and the orange. So the purple is the upper function, okay, while the orange is the lower one. So the purple minus the orange, purple is a y2, negative 2 over 3 x plus 14 over 3. Okay, we will subtract 3. So let's rewrite back. Here is a purple, which is y1 minus y3, upper minus lower function. Okay, on this side, the part B, this one is a y2 minus y3. Okay, this step is the most essential part to find the area. If you got them wrong, then everything after this will be wrong. So make sure they are correct. Okay, upper minus lower, upper minus lower. Okay, if we are referring to the x-axis. Next, so I'm going to simplify the function first before I integrate. So 0 to 1, so x squared plus 3 minus 3, 0. So dx plus from 1 to 5 over 2, negative 2 over 3, 14 over 3 minus 3 is 5 over 3 dx. So now the function has been simplified. Then we integrate. So x to the power of 3 divided by 3, square bracket lower from 0 to 1, plus square bracket, oh, you got negative 2 over 3x. Then when we integrate, we're getting x squared divided by 3 plus 5 over 3, starting from 1 to 5 over 2, equals 1 over 3 plus 3 over 4. And your final answer is 13 over 12 unit squared. Alright guys. Next page, example 17. Find the area of the region bounded by the curves y equals to x squared minus 5x and y equals to 25 minus x squared. Okay, there are two functions here. There are two curves. One is a positive quadratic, while the other one is a negative quadratic, 25 minus x squared. Okay, as usual, okay, we're going to sketch them first in order to describe how the region will be looks like. Okay, to sketch, so this is a positive quadratic function, x squared minus 5x, so x minus 5. So the roots is x equals to 0, x equals to 5. While on the other side here is a negative quadratic that will intersect at 25. So it's very simple. Find the root at 0 and 5. So let's start to sketch. So just a simple sketch. So 0 and 5, so let's say it's around here, 0 to 5, 0 to 5. So how about this root here and here? So the roots is negative 25 minus x, 5 plus x, so 5 minus x, so x equals to plus minus 5. Okay, so I'm going to sketch the y2 first, 25, and the y1, which is the positive quadratic, okay, is x squared minus 5x. So we are taking the yellow one, so the graph is smiling, which will hit 0 and 5, okay, something like this lah. Okay, so now the region, so the region bounded by these two curves must be bounded by these two colors, which is red and yellow. So we could see obviously the region is here, bounded by the two colors, yellow and red. Before we could find the area, we must first find the intersection point. Okay, here is 5, okay, alright. Here is 0, okay. But how about this? Okay, at that point, the intersection points is between y1 and y2. So as usual, we would equate these two equations. So y1 equals to y2, so x squared minus 5x equals to 25 minus x squared. So result to a quadratic equation, 2x squared minus 5x minus 25 equals to 0. So it can be factorized into 2x plus 5 and x minus, so now our x is negative 5 over 2, and also x equals to 5. So x equals to 5 is already here, so this point here is a negative 5 over. So now I am referring to the x-axis to find the area. So when we look at the x-axis, so which function is the upper function and which function is the lower? So if you can't see, let's draw the vertical line. Okay, I just draw the vertical line here. So we could see the red one is the upper function, while the yellow one is the lower function. So now let's get started to find the area. So area equals to, okay, the integration from where to where? From negative 5 over 2 to 5. Okay, so which one is the upper function? The red one. The red one is x squared, sorry, 25 minus x squared. So 25 minus x squared minus 5x with respect to, okay, there is no need to split, okay, to split this region into two parts or three parts, because if we see closely, okay, look closely to the function, to the region here, from negative 5 over 2 to 5. If you look from negative 5 over 2 to 5, obviously only two curves involved. There is no other curve. So straight away, we could just substitute into the formula of area between two curves, which is y2 minus y1. Okay, we simplify with the function first before we integrate. Okay, we have here 25 minus is a minus 2x squared plus 5x, all of this with respect to x. Okay, so now we integrate. So we're getting 25x minus 2x cubed 3 plus, okay, so the lower will be begin from negative 5 over 2 up to 5. So we're going to substitute the upper limit first, 2 over 2. Okay, this step must be done. Okay, then just simply use your calculator, okay, to find the final answer. This step must be done. Okay, must be written clearly. 25 negative 5 over 2 plus, so minus 2 negative 5 over 2 3 over 3 plus 5 negative 5 over 2 3 over 3. Okay, K1 for this step, and then the final answer is 140 5 over 8 units squared.